Hi everyone, my name is Farid Zidat. I am PhD Senior Application Engineer within Altair. I am going to show you how to compute the constant torque KT of a permanent magnet machine. So let's start from a project solved and defined in transient application with IPCN working point. So the IPCN, so the current sources are imposed here with the current defined as a formula, and we impose the speed, right? So this is the post speed with a given value and initial position. Please note that there is a video already explaining how to determine the initial position. Then the current are defined as a function of time and the value, the RMS value of the current and the gamma. Please note also that there is a video now explaining how to compute gamma using Flux. So we are going to delete all the results here from this project and convert it to a magnetostatic application. So let's see that it's magnetostatic application, and we'll call it demo. Okay, then the conversion will be done. Please note that the initial transient project had a solid conductor region, and here when we are going to make a conversion, actually the magnet that were defined as solid conductor region, they are now inactive. So we have to define them again with the right material and the right orientation. Okay, so let me define it again. So please define also the right orientation for your magnet and do not forget that. What I am going to do also is to have a look on the formula of the current. They were defined as a function of time. Here time, there is no time in magnetostatic, so I am going to replace time 1, which is created during the conversion, by simply 0 here. Okay, and gamma here is defined by formula. I'm going to define it by scenario. Why I need to drive gamma? Because for each current supply I am going to use, I need to recover the maximum value of the torque. So gamma should be varied as well. And the current here is defined as a formula. I am going to define it as parameter driven by a scenario. Okay. Once I did that, I have to create a scenario where I have to vary the current, the gamma. Then here, the first of all, I have to fix the rotor at its initial position at 11 degree. Then I have to come back to my parameters. So the current, I have to vary it from maybe 100 to 1800 with a step of 100 amps. And I have to vary gamma as well from, let's say, from 0 to 90 by a step of 1. Okay. So as you can see, there are a lot of configuration. I suggest you use the parametric distribution here. Okay, then once this scenario defined, now you can solve the project. Solve the project in a new project. So let me open then the project. I have already. Okay, so the project solved here is, as you can see, versus current variation and the control angle gamma, and I fixed the rotor position to 11, which is the initial position. So now, since the project is solved, I can create a 3D curve now of, let me call it torque as current gamma. And here I am going to select electromagnetic torque, okay. And as you can see, this is the torque I obtain. So for each current, I have a torque, and as you can see, the gamma, the control angle gamma, is not really constant. So the value is varying versus the current supply. So it's depending also on the saturation, right? So here, once I had this curve, I need to plot to recover the maximum value for each curve here, for each curve of the torque versus gamma. So we have useful macro, then I will load it now. It's called extract from 3D curve. Then I can run this macro, right click, run, and I will select the parameter current, and I will just indicate max. Okay, and then it will extract the maximum value for each curve here of the torque versus gamma, and it will plot the final curve as the torque, maximum torque versus the current value. And here you can see that there is a linear part and a kind of saturation of the kt. So the kt is the slope of this linear part actually. And now we can see that for each value of the torque, we have its corresponding current value. Yep, that's all for me for this video. Please feel free to contact us to the support or on the forum, or maybe let a comment here for the video. Thanks, bye.